everyone. Today we have our another new episodes and we have very interesting topic 3D multi-sensor transmissions. And I'm very happy when actually different universities and different government people and corporation they communicate with World Talent Economy Forum and they learn a lot from our speakers. Every moment they understand what they have to do. Both of the speakers they are very successful CEO. Uh, David Smith and Mr. Marshall. Uh, Both of them has very unique vision, and they are trying to solve many problems in the developing world. So hopefully this journey and this kind of collaboration will help us a lot, especially the developing worlds. And we are very happy that we are launching many interesting projects in Asia, Pacific, and Africa. So uh, contribution from Professor David Smith and Mr. Marshalls will be very very helpful for the people of developing world. So first I want to request Professor David Smith to analyze today's topic 3D multi-sensor transmission.
Well, Sharif, you always choose fantastic topics. And if you look at 3D sensing in many ways is a game changer and is a very interesting scientific breakthrough. Uh, it's in depth sensing technology that can augment camera capabilities for facial object recognition. And what happens is it's the process of capturing a real world's object's length, width, and height with more clarity and more in-depth details that can be achieved than just putting together multiple technologies and trying to do it as well. Um, we when we look at the way we live in a 3D world, but most of the things we work with as we try to design, as we try to document, as we work with other things like that, it's a 2D world. So you do not get to see the differences there. Um, it's a real game changer, the 3D sensing, as manufacturers try to put these new advances into consumer products, such as our mobile smartphones and other things like that. And 3D sensing is a technology that really mimics the human vision system. Uh, and it facilitates the integration of augmented reality, the Internet of Things, advanced manufacturing, autonomous driving. All of these things are going to rely on 3D sensing technology to be successful. Now, with it being used that much, the market is today in 2021 about a $3 billion marketplace. And by 2026 is expected to grow to around a $10 billion marketplace. So it's roughly a 28% compound annual growth rate. And one of the places driving it also is the gaming industry. And the gaming industry is very much trying to become a 3D gaming industry. And like I said, you see it in automobiles, you see it in manufacturing, you're seeing it applied in healthcare, you're seeing it applied in consumer devices, and so many different ones going across it. As we've talked about robots before, 3D sensing is very important as we use robots, both traditional robots and cobots, which are the collaborative robots. So you see those technologies be really beginning to come to play there, and the difference. Uh, Let me go ahead and at this point talk about the other big change you're about to see with 3D sensors is, let me kind of get back. The 2D sensing is two-dimensional, length and height most of the time, and it's kind of flat. 3D is length, width, and height. It's what we see every day, but where we're seeing sensors also going is into fourth dimensional. So what 4D is its length, width, height, and time and motion. As we think about the things we're doing, like manufacturing, as you think about how we're using sensors for autonomous driving, as you think about what a robot would need to do, uh, with 3D sensing. You can see that there's going to be a fairly heavy, rapid R&D push to move this to 4D sensing as well. So to me, that's kind of my introduction.
Thank you, Professor David Smith. Mr. Marshall.
I think that's an excellent introduction by David. From a immediate implementation point of view, I think this capability is really critical for advancing what we talked about in previous panels, such as the robotics panel or the artificial intelligence. When you start to marry the sensory capabilities together with artificial intelligence and robotics, you actually have the capability to deal with a lot of issues. The one that comes to my mind are three topic issues of importance would be climate resilience and climate adaptation, which is really critical, especially in not just in certain countries, but all over the world. We know after COP26 that we are on a time of the essence timeline. If people don't know that, they should reach out to me and I can explain that. But basically, this technology allows us to be more integrating in our capacity to deal with climate change, also with healthcare issues, and also with educational component, which is important in healthcare and climate. Because if you can't educate people, they are not knowledgeable. They don't have the capability to deal with what's going on. And education is really paramount at this point in time. So we need these technologies to be able to be integrated and give people the ability to use them for the future. It's not enough just to deploy them. You have to have people that know how to deploy them and know how to manage them and get the data from them so that we can improve quality of life issues, improve climate resilience, and improve healthcare. That's my shot at the beginning.
Thank you, sir. Thank you, sir. Dr. Churchill, can you hear me? Okay.
Hi, I
Yes.
can hear you. Yes. How are you?
Yes, I'm fine. I'm fine. Can you open your camera? We want to see you. And can you say something about 3D multi-sensor transmission?
Hey. Yes. Well. Glad to be here again and seeing you all together. That's fabulous. I just wanted to say briefly that I got nothing more to add than what already has been said, except that clearly the issue becomes that the more data we have, the more information, and the more conventional numbers you can get, you can actually crunch that and find the things that we need to do, the better off we are. That which is measured is managed. So this is where I stand. The more we have this capacity to the sensoring system to understand the world around us, that I yield my time. Thank you very much.
Thank you. Thank you, sir. Professor David Smith, as you are subject matter expert, what are the technologies and tools used to store, visualize, and analyze sensor data?
Well, Sharif, you're jumping right into the right place to this. Is that as you look at the technologies and things that are in 3D multi-sensor type things, you're seeing a lot of advances and changing. And the type of technologies that are used with these sensors really depends on the applications you're trying to do. One of the big changes right now in 3D sensing is there's a movement from LED and edge emitting lasers to something that's called a virtual cavity surface emitting lasers. And that's a mouthful. They're VCSELs. But what they're doing is they're becoming one of the dominant ways to begin to use with these sensors because they have a narrow spectrum. They're stable, low power, and you get what's called stereoscopic vision with them. And you begin to get other things which are needed. So stereoscopic vision is a technology that derives its structure from the way our eyes capture images. And how it's done is you've got two cameras that are slightly offset in position. You know, if you look here, I have two cameras that are slightly offset in position, and that's part of the way we do it. So just like with our eyes, these two captured images are then united into one picture using software. Again, the analogy to our eyes with being able to use this type of technology in 3D sensing is a perfect way to understand that. And that is how you begin to get the stereoscopic vision there. And you begin to see other ways. There's another take on this where you project dots on an object and do it. There's another way where you do a type of 3D image capture with it to get out it. And then there's a lot of different places where you see this technology in cameras installed for monitoring people's movements at door instances and other things like that. Another approach to this is what's called a structured light pattern. And with it, lines, squares, dots, or things projected onto an object by it. And a distorted image is created by the reflective light. And then we're using software to go ahead and take these reflective images and create them into a 3D image. So if I look at my iPhone, this is kind of the technology you see with what's called the true depth camera that's used on the iPhone. It has an infrared emitter that can project onto the face that you use, and it's what's part of its use to do the facial analysis in 3D that Apple uses as part of your authentication. And so they're using a 3D sensor on the screen side of an iPhone to begin to authenticate you there. And there's also something called a time of flight. And a time of flight is where you use images kind of like strobe lights to capture these images. And you see the applications pretty broadly. One of the questions, how are the sensors used in society? They're used very broadly, from things like what you just heard me say with iPhones, to tracking people going in, to looking at equipment in a manufacturing line, to you look at organizations like Amazon and Alibaba and others, where they're using robots in a warehouse to go and place and pick things that they're working with out of the shelves to deliver them. They are using this type of technology so they know what to grab. If I'm a cobot, like we've talked about earlier, they're using some of these technologies to be able to interact with the real world, to not walk through the table, to go around it, to be able to pick up a package, to be able to take our arm, take and grasp something like this. You have to use these type of sensors to have not just a 2D representation, but a 3D representation of the objects that you're interacting with. It is what translates our machinery into the real world. If I'm in an autonomous car, I don't want to see a 2D image in front of me. I want to see a 3D. Actually, if I'm in a car, I want to see a 4D image, because I want the time and motion captured as well. And one of the technologies you're seeing being added a lot now to 3D sensors is LiDAR technology. It's laser imaging, laser distance to it, so that you can move from 3D to 4D. It's, like I said, at the start where these sensors are going. So Sharif, I'm not for sure, but I think that answers your question.
No, excellent, Professor. Mr. Marshalls, I want to take a question from audience. What is the importance of sensor in entertainment industry?
Well, I think that's an excellent question. I think kind of David touched base on that. A lot of these sensors are used in gaming, technologies today. If you're, I'm not a gamer, so I don't know all the technologies, but I've got godsons and children and grandchildren that actually use these systems, and they know about it more than me. They could probably answer very readily. But since I'm not familiar with the gaming industry, I do know it's used in gaming. I do know that they're beginning to use it in broadcast of movies. If you remember the old-fashioned days when you'd go into a movie and you'd put on 3D glasses, that's kind of the grandfather of all this concept, and you'd see a 3D image on a screen. One of the things that I'd like to touch base upon, which David brought up, and it does apply to the gaming industry as well as to other use cases, and that is, I kind of want to drill down into the fact that as part of these imaging capabilities, one of the technologies that is integrated into 3D technology is hyperspectral imaging, and that's an image that does it gets information across the electromagnetic spectrum. So you're getting data on finding objects, on identifying different types of materials, which I think is critical when you're dealing with chemical processing. Also detecting processes, as David mentioned about going into a factory and you're watching people process things. It can detect human processing, but also machine processing. So hyperspectral imaging is really part of the technology base that could be integrated here. There are a number of spectral imagers that are out there today that are in use. There's the push broom scanners and the related whisk broom scanners. These are spatial scanning. They scan the spatial area, give you that three-dimensional capability. They're looking at each, what I would call each part of the spectrum, photon by photon, and aggregating it and giving you an image. And as David pointed out, Amazon uses this type of technology in being able to move equipment from one part of their floor to another. And I'm sure a lot of people have seen the actual videos of this going on. And there's also what's called a staring array that generates an image in an instant, which is important if you're talking about creating imagery that is real time. So I think spectral imaging is an important part of the component. It's not the only part of this whole array of technology that's being deployed, but it's important technology that we need to deploy on an ongoing basis, and it will develop and be adopted as we move forward.
Thank you. Dr. Churchill. Dr. Churchill. Can you hear me, Dr. Churchill? Sorry, if we have more questions from audience. Professor David Smith, you give an excellent analysis about the sensor. So some basic question also coming from audience. How sensor used in societies and how do sensor make our everyday life easier?
Well, you know, I saw those over in the channel, and I love as you begin to look at those topics. So let me kind of put it in different areas. For example, if I look at consumer electronics, you see 3D pictures, you see video, and mobile phones is one of the big applications there. So you see it with things like facial recognition. You're seeing 3D beginning to be used, as we talked about earlier, a lot in gaming. When I'm on my consumer device that does gesture recognition, and it wants to recognize my gestures, that's a 3D sensor that's being used to recognize my gestures. Eye tracking, we're beginning to see in secure commerce, secure banking, and other applications like that, where it wants to do. When I take my iPhone and have it unlock my screen by looking at my face, that is not a 2D representation of my face. That's a 3D representation of my face. So you see those applications. You see them in automobiles. You see them in vehicle access. You see them in touchless dashboard control. and other applications like that. If I go and look at autonomous driving, I could not do autonomous driving at all without 3D, without 4D chips and systems to accomplish 4D autonomous driving. One of the other places you're seeing them used a lot is in the new generation of drones. And drones, they do object detection, they do collision detection. And Nika has the question there, can sensors really save lives? Yes. If I look at autonomous trucks, autonomous cars, it's the 3D, 4D sensing that is used to prevent you from hitting the car in front of you, from hitting the person walking across a crosswalk. You're seeing 3D, 4D sensing beginning to use in healthcare in a large way. You're seeing minimally invasive procedures used built on it. You're seeing, for example, proton light technology uses 3D types of sensors as you begin to take that area and make it work. In industrial, you know, I need 3D sensors to do 3D printing. It kind of makes sense, is that
Yes.
if I'm going to print it and build it, I have to sense it. So most of the places we're seeing 3D sensing where it's invisible to us. I mean, again, most of us never realize that when we use the camera that's on the screen size of our Android device or our iPhone, that's actually a 3D sensing camera. And that's how it begins to do it. Many times in our cars, if we have a car that has the ability to change our speed based on the cars in front of us, or a car that has assisted stopping, that's because of 3D technology. If we have a car that says, lights the light up in a mirror on the dashboard that says, gee, there's a car right next to you, don't pull into it. That's 3D technology. So is it used in society? Quite a bit. Quite a bit of the use in it is invisible, though, to us as humans, which is what's so neat about this technology. And once again, where this technology is really heading is from 3D to 4D sensor technology as a system. You've heard me talk about a system of systems many times. Well, 3D multi-sensor technology is really a big part of a system of systems, because that sensor won't do anything for you if it's not part of other systems. So the 3D sensors, the 4D sensors are really one of the big enablers as we look at some of the other systems of systems. So I hope that answers the questions from the audience right now.
Excellent. Mr. Marshall.
Yeah, I would add. I think David's comments are spot on. I would add another life-saving capability of this imaging technology is used in what's called biomedical imaging, especially for surgery. He's talking about saving lives so that we don't crash into each other, or a drone doesn't crash into you or kill you or something. And that is really relevant, and that's probably the highest priority. But also, biomedical imaging uses this. There's new scanners out. There's a new test out to determine blood flow in the heart. It's called catheterization. And I now know that they're using 3D imaging for that. And I've actually seen videos that support that. So it's like they're taking a 3D video of the blood flow of the veins or the arteries of the heart, and even of the heart itself. So, and I know that the other parts of the body do that. So that's really life-saving technology right there. Some of the other areas where technology is being deployed is also agriculture, which is in a realm that I'm involved in, where we take agricultural waste and we convert it either into energy or a material known as biochar. And the pyrolysis systems used to be where they just take the flow in and they process it. But we do much more with it, where we have sensors, like David mentioned, like a cell phone, right? Like this camera cell phone, where we get 3D imaging of the processing of the type of char that's coming out the back end. You not only characterize it chemically, but you also characterize it visually. You need to know what the granular size of the char is, where, so that you can know where it can be used. In addition to that, there's, it's used in physics, geosciences, astronomy, obviously other science uses. But I think the ones that we're involved in, which are critical to applications today, is where we're taking waste, converting into material. And we know that every time you transfer something into and you thermally convert it, you're creating a unique fingerprint. People don't think of it that way, but we do. It's like the material, like for instance, if you're taking cow manure and you're going to convert it into a form of char, the moisture content is high. So you get that moisture content down, then you can thermally convert it. And depending on how you convert it, it's like being a chef. You're creating different types of chars out the back end. And one of the ways you want to keep track of that is a visual tracking of that capability. And of course, big data technology integrated with this imaging technology allows us to process the information in real time and get outcomes and understanding of where it can best be used in the marketplace. So those are some of the use cases that we're involved with. Hopefully that
Thank you.
adds to the conversation.
Yes, Dr. Churchill, can you hear me? Okay, I don't know. Professor David Smith, what are the latest development in measuring physical exertion? Or like, what is your view about like how actually we can do more research on sensor and how it will be helpful for saving our lives?
Well, there's a lot of application there. I'm going to actually share one thing, just a really quick picture, which I think will help there. Let's see if this. So the picture I have up here is just really, let me blow it up though, is the picture inside a factory. And each of those are robots which are going and moving stuff autonomously around it. But what's really interesting if you look at this is you see it has to have sensors to know where all the other robots are, where all the other packaging is, where all those other elements are. And see, a lot of the research that needs to happen in this area is really going around not just how to build the sensors, but how to integrate them into the other devices, like the robots you saw there, in the cars we've talked about, in your smart devices, in manufacturing, in drones, in entertainment, in a game controller, and how to begin to do that and use it. So the research is there, but part of the big research is to take that and put it into an application in an ecosystem. So those robots you saw there, it wasn't one robot. It was multiple robots working together. And how can I put together an application, a software system, a framework that can help it where I can take these types of 3D, 4D sensors and make them work together with each other? It's one thing to have a sensor that's doing a repetitive thing, to reach down, pull up my phone, put it over here, take another one, put it back over there. But to act in real time in the real world, that is where a lot of research needs to be done. That's where there are tons of entrepreneurial opportunities. I mean, just think, how did a Roomba vacuum cleaner come in place? It did it because of 3D, 4D sensors. To be able to take a little robot as a vacuum cleaner, put it in my living room and say, go clean the living room up and don't miss a spot on the floor. It does it through integration of this type of sensors into the software in it. But if this type of advanced sensors can be applied to something like mopping and vacuuming my floor, just think about the number of entrepreneur activities that can be there. Think about where they can be used for scientific advancement. Think about how a government can begin to use this to optimize traffic flow within a community. Think about how it can be used to change how we do medicine. Think about how a government might want to do these to automate delivering packages and mail, to use it in drones to do new surveys. I mean, I could sit down and brainstorm 1,000 usages of these and products without much effort. So the opportunity, Sharif, for the communities, for the universities, for the entrepreneurs is really very large. It's one of the places where I'm going to go back and if you build it with this technology, I think they will come. As Nike says, just do it with this technology. And I think that is where we will see it in universities and entrepreneurship. I could really take this. I could see this technology being expanded even further in healthcare. With COVID-19, with COVID, this type of sensors is going to be really necessary as we shift from going into the doctor for everything to doing more healthcare by telehealth, telemed at home. And the big next advance in telehealth, telemed is integrating sensors like this at your home so that the things that a doctor might do with you in the office becomes, because again, when you go into the office with a doctor, you're in 3D. If I just connect to you by video like we are now, we are seeing each other in 2D, not 3D. And so if I'm really sick, I really want the doctor to be able to sense me, feel me in 3D and not just the 2 dimensions like we are now in this broadcast. So again, the opportunities are almost what you can imagine using it for. That's why I said at the start that as you begin to look at this type of technology, it really is a game changer. And this 3-dimension sensing technology is a huge scientific breakthrough because of how ubiquitous it is with transmitting our 3D world to machines, to devices, and using the devices to help interact with us in our 3D world. Because if you think about it, when I look at my iPhone and use my facial recognition on it, it's making 3D points on the facial recognition. It's measuring the differences between your eyes and your nose and your lips and your ears and stuff like that. And that's more than a 2D representation. So again, a lot of applications, and I think it's a place where people in your audience, over a good cup of coffee or a good margarita, can come up with many applications to do things and new business ideas with it.
Thank you, Dr. Churchill. Are you with me, Dr. Churchill?
He came on video just a minute ago.
Yes.
I am with you. Yes, indeed. Hi. So go ahead.
Yes, we are discussing about sensor, 3D sensor. So there are many questions from audience. You can respond. How are sensor used in society?
Yeah, well, some of the projects I'm involved are space related. So obviously I can tell you about that. One of the more current issues of the COTS is orbital vehicles that are being serviced. This is a new industry into which you can actually service the satellites that are bobbing about, on the space surrounding the Earth. And this is brand new, and the amount of sensor support that you need in order to do that is probably, extraordinarily difficult to describe. But the function is not so very different than a lot of the autonomous driving vehicles or a lot of the other applications that we've seen for the sensors that we are talking about. One of the most important things is that I innovated the last 10, 15 years with the space tag. And that is exactly what the word implies. It's like a tow truck in space, to find and support satellites and their relevant, spaceships. Now, the sensors that we use there, they're actually quite complex, but they're always, four-dimensional. There is nothing two-dimensional in space. So that's something to bear in mind. Other things we are talking about, in medicine, we have the sensors that we enter into the bloodstream. And those are tiny, tiny, obviously objects that can provide data for a very long time coursing through the body of a human being. So yeah, they save lives, and at the same time, out on Earth and out in space, they augment our capacity to communicate and support satellites. That they do all sorts of wonderful functions for our facility on Earth. Thank you.
Thank you, Mr. Marshall. We are discussing some important points about 3D sensor transmissions. Professor David Smith and Dr. Churchill also bring some interesting point. My questions to you, like these are the things, especially the developed world, they are doing a lot of interesting research and they are managing these things worldwide. You have your own corporations. Dr. Professor David Smith also has their corporations. So my questions to you, it's completely different point of view, like how you encourage research or how you invest in research on different topic. Let's say the 3D sensor transmissions. How, as a CEO, how you want to encourage? Because in developing world, I know that many corporation has financially they do not have problem, but they have little bit of challenge or problem. They do not want to invest in research and development. So, what is your advice?
Well, that's an interesting question, Sharif, because that's a problem not just in third world countries. It's a problem in Silicon Valley itself, where everybody talks about, that Silicon Valley is the cutting edge around the world for all the technologies that people think about America for, which is a misperception, in my opinion. Silicon Valley is known for computing. It's known for imaging. It's known for all sorts of things. And of course, it relates directly to what we're talking about today, about the imaging and the 4D and 3D technologies that are coming about. A lot of them are being developed in Silicon Valley, but also in other Silicon Valley type environments around the world. Our approach is to encourage mini Silicon Valleys. There's an Arabic word for a valley. It's called a wadi. A wadi is like a dry gulch in America, where when it rains, the water flows through it. So think of the rain being the funds, and being able to create the capability to fund the mini R&D facilities that you're talking about around the world. That's the way we would look at it, and we believe there's a way to do that. And I'm sure in the future forums we'll be discussing how to fund innovations of that kind. But our approach has been actually to align applications and use cases to R&D and vice versa. I'm going to go back to what we're talking about this topic. When we talk about imaging or 3D imaging or 3D solutions, part of it, as David pointed out, you have these glasses that are kind of primitive technology, but we use it to have greater clarity on what our vision is for our human vision. When it comes to computer visions, though, they can use more than one pixel, and they can have a spatial resolution that's far greater than the human eye, or even greater than any other species on the planet. That's what's really remarkable about this technology. However, there is a challenge, and the challenge is what in communications is known as the signal to noise ratio, but also known in physics. In other words, if the resolution is very minute, and you can get pretty small resolution out of this technologies today, the question is it too small for the robots to go around on the factory floor? Is it too small for space deployment? The issue is it's not, generally speaking. But it's a challenge that scientists are always addressing. And when it comes to training people, you need to be able to make sure that if you're using this technology for training, you need to make sure that it integrates with human interface as well as robotic interface. Robotics can handle a lot more, like we're talking about the car, that's the self-directed car. It needs to know at when to stop, when to speed, what's around it, so it can censor all that. And in the factory floor, the sensors are even greater because you not only need to know, coordinate with maybe hundreds of other robots, but also where they're going, how they're going, what they're going to avoid. All that is spectral imaging, and there's also the signal to noise ratio challenge that needs to be addressed, and we're addressing it in various capacity. But I'm just putting that out there as one of the challenges, and that if it's going to be deployed, we have to keep it in as an interface with humans, with people being able to take over when they need to. So that's hopefully that answers the question or addresses the issue that you just brought up.
Thank you, Professor David Smith. One of the important aspects about research, you are also running corporation like ETT, one of the largest corporations. So how you want to encourage research? Is it helpful, or what here?
Well, I think research is very important in this area. And I'm going to break down research wearing multiple hats. And so if I'm looking at scientific research, I have scientific research in the sensors themselves. I have scientific research in the enabling components used. You heard me earlier make the comment that the lights we use for this are changing with the different types of lasers we're using as we begin to transition through different laser types. There's a lot of research that has to be going on. How do we integrate these into systems? So there's software research, there's systems research. There's actually research on how can we do this with the interaction with humans. So the human machine interfacing, which is enabled by 3D and 4D sensors, really needs a ton of research, because in it, for example, with a cobot, a collaborative robot, the interface between the machine sensing, between the machine grasping and doing stuff as it's working in real time with the human, I don't think we understand well enough. As we apply these sensors, there's social science research. Where do we look at the ethics that are involved? How do we look at how it's going to change society? We've talked before about one of the benchmark interfaces between artificial intelligence and 3D, 4D sensings with a challenge. If I see a child in a crosswalk, do I hit the child? Do I hit a bus next to me? Do I do something that might injure me? In addition to that, there's that scientific research, university research, that needs to go in to understand the interfaces between artificial intelligence, this type of sensors, and the systems they are involved with. Then you have more type of research in an academic institution that is not scientific research. It's going over into, for example, into a business school and beginning to say, I now have these as a tool in my toolbox. What can I do with it? How can I look at elements of this? You have research in, can I lower the cost? Can I increase the capabilities? How do I do massive integration with these? Because one of the real things about 3D, 4D sensors is by themselves, they don't do much. They have to be integrated with other things. And that is an area of research that is almost endless today with how they can be applied with other things.
Thank you. Dr. Churchill, you want to add some point about research, importance of research, and how you want to encourage researcher?
I'm afraid that today's pandemic has proven that the research money that we spend might have been a little bit misspent, in the sense that we haven't been focused on looking at the exact issues that are relevant to our health, for example. Now, when you're talking about censoring and sensors that are relevant to healthcare, now this would be a huge thing. However, the research money is not available to that, as it does not treat or addresses the research to the root causes of the problem, but we are always, one step behind by trying to find solutions, of course, for the most imminent end game. So I think that I would agree that perhaps we should look at researching at the earliest possible stage, and censoring, of course, censors would help us greatly for that. So it's very difficult to consider, how research can be spent or misspent. And I don't know, by some sort of general definition, the majority of the research done is actually money that was misspent. And it might be just all the way up to 90%. However, for the little research that's actually very successful in helping us, yes, that makes it all worthwhile. And I guess this is the case as well. So yeah, that is very much in line with what everyone else is thinking.
Thank you. Thank you. I want to share that next week, Friday, we have an interesting debate. Definitely, I want to request Mr. Marshall to joining this debate. Professor David Smith will join in the debate. Dr. Churchill, you can join as a audience as well as a judges for this debate. We will arrange some of the professional debate from next week. Why it is important? Because we are heavily involved with academy. We launched Asia Debate Academy 2012. And 2013. We have experience to organize World Debating Championship, Asia Debate Academy. We used to work with Oxford Union, Cambridge Union, Harvard Union. And this time in World Talent Economy Forum, we want to launch a professional debate, like CEO, like Mr. Marshall, Mr. David Smith. They will attend in the debate, and already it's created a huge impact. Many media already communicate with us that who is the speakers, who gonna join, what is the topic. Topic already declared. So this will be another interesting debate. And already International Islamic University, you can say them Oxford of Islamic world. They also produce many champion debaters. They are also champion in Oxford Ivy and Cambridge Ivy. They are also supporting World Talent Economy Forum initiative. And in the future, we want to arrange more debate on AI and human. Last time, IBM arranged this debate. So the Harris Natarajan, he also part of Cambridge Union. He was my very good friends. So we will arrange some debate, because debate actually help us to develop some critical analysis. And most important thing is that this is the way how we can develop best human resources. On the other hand, World Talent Economy Forum has excellent resources like today's speakers, those who contribute a lot in corporations. They know what is the demand of the corporations. Some point, academy and corporation
what is the
has some,
subject of the debate?
our subject I'm just sharing. We will do debate on artificial intelligence, and our debate topic is this house believes that humanity should fear advances in artificial intelligence. There will be 3 speakers from the government and 3 speakers from opposition. So yes, definitely we will arrange more because it has huge popularity. Already many union like IIM oratory clubs, like Oxford Union, like Cambridge
So
Union,
it has
they are
to do
also
with the fear generated against artificial intelligence. If I heard
actually
correctly.
actually our debate that on the awareness of artificial intelligence. One
Awareness.
yes. Yes, we will create
Very
awareness
good,
for
very good.
artificial intelligence,
Very
and
good, very
especially
much so.
our students, our youth community will learn from industry. every moment what
Yes.
actually Professor David Smith, Mr. Marshall sharing with World Talent Economy Forum. We are heavily utilizing it for our classroom management, for academic development, and we have a plan to develop world-class conference in Malaysia and Singapore. We have a plan
Yes.
for next year. Well, already we are working with IEEE, so we are collaborating with IEEE. Hopefully, your contribution will give us uh, a new generations for developing worlds, a new peoples, and I believe we can arrange more
Yes.
interesting
Yes.
debate in the future. Mr. Marshall, anything you want to add?
What is the date? Which Friday is that going to be? The date?
Date will be
24th.
24th December.
Oh, okay. All right. Not tomorrow.
20,
Okay.
no,
Right.
24th December.
All right.
We declares we run as a Asia Debate Academic Directors. We already produce around 3,000 debater in Asia. We have many debaters, those who are world champion even. You can remember in 2013, Bangladesh was world debating champion in Germany. I'm also part of this team. So we will produce world high quality debate, because debate has many popularity, and local media, especially from media from Asia Pacific, from Malaysia, from Singapore, from India, even from Africa, they will promote our event.
Bye
So thank you
bye.
for joining
Thank you,
today's
Sharif.
session.
Thank
I
you. I'll see you next time. Bye bye. God
thank
bless.
you, thank you,
Happy
thank you.
holidays to everybody. Cheers.
Thank you. Thank you. I want to go for the concluding remarks. First, I request Mr. Marshall, what is your concluding remarks?
Well, I think it's important to, as we've discussed today, that these 3D sensors play a major role in integrating other technologies such as artificial intelligence, robotics. Without 3D sensors or 4D sensors, the artificial intelligence can be deployed, but you're going to get a better resolution of use case in the different topics that I know that we're involved in. And I'm sure it's the same case for, I mean, we're not involved in medical per se, but we are tangentially touching medical issues. So we know that with 3D sensors, and as we saw in catheterization technology and other technology, being able to have 3D sensors supports the use case for medical professionals, doctors, cardiologists, cardiac surgeons. The same thing with on the front lines of handling waste and being able to handle it and get better use out of that waste, so that it's no longer a waste. The waste actually becomes a supply chain to environmental products that lower environmental impacts, that improves soil health, improves air quality, and improves water quality. Those are things that 3D sensors can actually contribute to. There's many other use cases, as Dr. Churchill had mentioned before he got off, and that is astronomy. He's been dealing with outer space. So we know that both here on Earth and in outer space, this technology is applicable. And I think David has brought about a lot of other use cases as well. So that's my concluding remark.
Thank you. Thank you. Before I give chance to Professor David Smith, next week, Tuesday, I think 21st December, Tuesday, there is a very special episode about climate financing emergency. Both of the Professor David Smith and Mr. Marshall will join in the event. I think we have more speakers. I request all of our audience. Already, we communicate with different government, different developing nations government, different corporation, different developing bank, central bank. They will be our audience, and definitely we want to arrange a series of talk, because these are the things very important. Because climate change is very important. Example, I'm from Bangladesh. Bangladesh heavily facing challenges for climate change. Even where I born in Rajbari, a small district. We lose our land in and everything. So how Mr. Marshall actually offering solution, I'm really impressed. And we already discussed with many countries, important countries, even we communicate with Prime Minister Office in Bangladesh about your solutions. Professor David Smith also have excellent solution for developing world. So we want to arrange this kind of series because we want to take action. Action is more important. Dialogue, definitely this is also important because it will create awareness. I know many of the people, they do not know what they have to do next, what will be the solution, what will be the strategy, how they can develop better policy, how they can save their country. This is the important. So I'm observing how Professor David Smith, Mr. Marshall actually supporting World Talent Economy Forum. We are very much impressed with their support, and definitely we will develop some project, real life project, which will be very helpful for developing world. And I can assure you from World Talent Economy Forum, this is not actually our 1 year, 6 month of initiative in online, but previously we done many projects and many work. So hopefully we can save humanity through your process, through your strategy, through your corporations. That is our major objective, World Talent Economy Forum. That's why we say economy forum, because we need to do something for economic sustainability. So thank you, Mr. Marshall, for your excellent offer for World Talent Economy Forum. I want to give special thanks. Beside that, I'm really impressed by Professor David Smith, how you continuously support World Talent Economy Forum, how your corporation actually providing solution to the developing world. This is also important. So next Tuesday, we have very important episode, and we are ready to arrange a series of episode, because how you contributing, our people has to know more, they have to understand more, and they have to engage with this kind of initiative. So thank you, Mr. Marshalls, and thank you, Professor David Smith, for your initiative. So, Mr. David Smith, what's your concluding remarks?
Well, Sharif, thank you again. Enjoyed the session today. I'm going to pull back a second. And there's something that I actually helped create decades ago called an intelligence chain. And what an intelligence chain is you start with what it is you're looking at, and then you have sensors. The sensor gives you data. We turn the data into information, and then we want to have knowledge, wisdom, and action. 3D sensing, 4D sensing is the part where it's the sensor looking at the real world that gives us the data that we turn into information, knowledge, wisdom, and action. So that intelligence chain is something that can be applied to most problems. 3D, 4D sensors are a key part of us being able to take that intelligence chain and apply it to doing good things. So really my conclusion on this is that 3D sensing really aims at connecting devices with the real world to enhance the end user experience, to enable things that we cannot do before, to give us advances in manufacturing, healthcare, autonomous driving, and things. What has really helped accelerate this, though, is the increased adoption of 3D sensing in smartphones, because what that adoption in smartphones is doing is it's driving costs down, it's driving power consumption down, and it's driving up performance. And these greater capabilities, greater performance, lower power, smaller packaging size is enabling the expanded use of 3D sensing in many other applications. We could not do collaborative robots without using this type of 3D sensing to make it possible. And one of the big gaps we still have with this is we need to test them more, we need to integrate them more, we need to work on the interfaces that they have with others, because all of our 3D sensors, when you look at the applications we're using them in, they have security implications, they have privacy implications. As we talked before, they plug into systems where ethical decisions have to be made. As we make these 3D, 4D sensors smarter, just like we're moving from cloud computing to edge of cloud computing, the sensors also have to begin to have more intelligence placed into them. So those are some of the big gaps in places we can apply a lot of work with it. But 3D sensing is a major scientific breakthrough that has enabled most of the advanced applications we've been talking about actually for the last week or two. So Sharif, great topic, and one that is really applicable to not just developing nations, but developed nations as well, and is applicable from in space, on the ground, in the air, and underwater, because that is places that all these types of sensors are used. So Sharif, thank you very much.
Thank you, Professor David Smith, Dr. Churchill, Mr. Marshall, for your continuous support for World Talent Economy Forum. And I will be really happy, beside this dialogue, creating these awareness programs, if we can take some action and if we can develop projects and we can help millions of people in developing world. That is our objective. And I find you have excellent things, excellent, even already from World Talent Economy Forum. We discuss with many organizations. We have very strong database. We always discuss about the solution, because I always believe that developing nations has lot of problem and they need lot of solution. They need great entrepreneur like you who can solve the problem. And most important thing is that those who have knowledge, they are the important, and that's why we develop this talent economy. You people are talent, you have the opportunity to solve the problem, and World Talent Economy Forum will facilitate all of your activities. Thank you, bye bye, and take care.
Thank you.
Thank you.